In section 7.5, we're going to look at starting to solve equations. Some of them are exponential, some of them are logarithmic. For today, we're just going to look at solving the exponential ones. Tomorrow, we'll start looking at how we solve log equations. There are two methods for solving exponential ones. The first is to get a common base. This is typically the easier method, and it usually doesn't require a calculator. Okay, so if you can find a common base, I want you to go ahead and do that. All right, so looking at this, we have 16 and 8. Is there a number I can use that would be a common base to both of those numbers? I could convert them both to base 2. Yep. So I'm going to rewrite 16 as what? 16 is 2 to the 4th. That 16 is being raised to the 3x. So my 2 to the 4th gets raised to a 3x power. On the other side, 8 is the same as 2 to the 3rd. And the idea behind this is if your bases match and the two sides are supposed to be equal, then your powers have to match. Okay? We've done this, yes, we've done this already in this chapter. Okay? In a slightly different context. What happens when you have a power to a power? Multiply. So we end up with 12x having to balance a 3, which means x would have to be 1/4. Okay? All right. Our next one. What base could we use with a 27 and an 81? Base 3? All right. So 27 is 3 to the 3rd. It's being raised to a 3x power. 81 is 3 to the 4th. That means what equation am I going to solve? 9x equals 4. So my solution would be 4/9. Questions on that method? That's not the new one, right? You've done this a little bit before, just in terms of solving for logs. All right. If I had changed this 81 and it was an 82, would I have been able to use a common base? No. So I have to have another method that would work when we don't have a common base. What we can do is we can take the log of both sides. It's just like all of our other techniques for solving an equation. As long as we do the same thing to both sides, it's still balanced. It's still an equal statement. So the idea here, if you have a statement that says m equals n, these two sides are supposed to be equal to each other, then if I take the log of both sides, they still have to be equal. Okay? So if m equals n, then the log of m has to equal the log of n. Okay? All right, so for this one, 15 and 285. First thing I would do is say, can I get a common base? Right? If I can, that's the easier route. In this case, I can't. So I'm going to take the log of both sides. Now, yesterday when we talked about those properties, the last couple days, the properties for expanding and condensing, what did we say we did with powers in a log statement? We can move them out front and then they become multiplied to the other piece, yes? So I'm going to take this power, I'm going to move it out front. So I have 3x times the log of 15 equals the log of 285. Okay? The log of 15 is just a number. I don't know what the decimal is on the top, off the top of my head, but it's just a number. My calculator would give it to me, yes? If I did log of 15. Base here is base 10, so it's not a problem. My calculator can find it. That means I can divide the log of 15 to the other side. I can move it out of the way. So now I end up with 3x equaling the log of 285 divided by the log of 15. This should look familiar. We did this with the change of base, right? Where we took a log divided by a log. Okay. Make sure that you close off that first parenthesis before you divide by the second one. Go ahead and get that decimal on your calculator. Don't clear it off though, leave it on there. So I'm seeing 2.0873. Yes? But that's equal to 3x, so then how do we get x? Divide that answer by 3. So just hit divide by 3, and we end up with 0.6958. Okay? All right, our next one. We have 5 to the 2x equals 130. 5 and 130, there is no common base there. So let's go ahead and take the log of each side. All right, let's move our powers to the front. So we have 2x times the log of 5 equaling the log of 130. Now again, when I took the log of each side, what base did I choose? I chose base 10, yes? And I chose that because my calculator can handle base 10, has a common log key. Okay? I'm going to divide the log of 5 over. I'm going to get my decimal answer for that, log of 130 divided by the log of 5. And then I'm going to take that answer and divide out my 2. Okay? What do we end up with? For the final answer, 1.5122? Yes? Okay. Now, this is my preferred method because I think it helps you see that whole expanding idea, right? Moving powers to the front, why it works. I chose a base of 10 because I wanted my calculator to be able to find those decimals for me. I could have chosen a different base. If I have 5 to a power, and I take the log of both sides using a base of 5, what would happen? So log base 5 of 5 to the 2x equals log base 5 of 130. What's going to happen on the left side? Remember what we said? If we have the log of base b and b to a power, if these match, my answer is just the power, right? So in this case, I would end up with 2x. I have 2x equals the log base 5 of 130, and then I'd have to use that change of base formula, right? That says this would be log of 130 divided by the log of the base. Okay, I'm getting the same thing I had in the red. Yes? It's just a different way of looking at it. I don't care which method you use. If you want to pick the appropriate base here so that these drop out, you certainly can. You end up in the same spot. Okay? All right. I'm going to pause the recording. I want you guys to try this one. All right. Taking the log of both sides. My power moves to the front. And then I'm going to divide over the log of 4. So I have 3x equaling the log of 6,000 divided by the log of 4. And when you divided the 3 out of that, what did you end up with? 2.0918? Yes? Okay. Last question. It says resource management example here. Wood is a sustainable, renewable natural resource when you manage the forest properly. Your lumber company has 1,200,000 trees. You plan to harvest 7% of the trees each year. How many years will it take to harvest half of the trees? So the first question is, does this fit an exponential model? The beginning of the chapter, remember we talked about exponential growth and decay? And we said we have growth and decay when your quantity is increased or decreased by a fixed percent, right? Think of the money problems we had, right? We were gaining 4% interest, things like that, okay? Increasing and decreasing by a constant percent, then it's exponential. So they're telling me we're harvesting 7% of the trees. What does harvesting mean in this context? We're cutting them down, right? So we're taking this 1,200,000 trees, we're going to cut down 7% of them. So the next year, we don't have 1,200,000 trees, right? We have less. The next year, we're going to have less. The next year, we're going to have less. It's going to keep going down by 7%. So, yes, it's a reasonable model. We are decreasing by 7%. We're going to define the two variables. They are asking us to find time, how many years it will take until I've harvested half of the trees. So I'm going to let T be time in years. And I'm just going to let Y equal number of trees remaining. Okay, so I need to write an equation. I'm going to start out writing the model. Total number of trees I have. I'm starting with 1,200,000, and what am I doing to it? It's decreasing by 7%. So I'm going to do 1 minus 0.07. Yes, 7% would be 0.07. Okay. And then it's to what power? T. Okay. Now, for this specific question, they said, how many years will it take until I have what? Half of it. If I harvest half the trees, then I have still half of them left. Yes? So the number of trees remaining would be half of what I started with. What's half of 1,200,000? 1 minus 0.07, can I just put that as 0.93? Okay, so that's what I have to solve. In the beginning of the chapter, before we knew about all this stuff with logs, we solved this using the intersect feature of our calculator, right? We graphed the two sides and said, where did they cross? Where were they equal? Now we can solve it algebraically. All right, what's my first step going to be? Not yet. What would my first step be? Yes. Divide out the 1,200,000. Okay? I want to get the piece that's raised to the power by itself. So I'm going to divide this over. Well, what's 600,000 divided by 1,200,000? 1/2, right? We said we were figuring out half. So, did it even matter how many trees I had to start with? No. This equation is going to work and tell me how long it will take, regardless of how many I start with, if I'm taking out 7% of them every year. Does that make sense? Okay. Now I can do the log of both sides. I'm going to move my power to the front. So I have T times the log of 0.93. It equals the log of 0.5, 1/2. Now I can divide the log of 0.93 to the other side. What do we end up with for our time? Okay. So in about 9.5 years, we'll have half of the trees remaining. Questions about that process? Okay. So your assignment is not what I originally had on here. We are going to go and do a Delta Math assignment. All right, so here's what you guys need to do. Some of you were in my class first semester and already created an account. I need you to edit that and select Algebra 2 Semester 2 5th hour, so you're in the right class. Those of you who haven't been in my class, you are going to need to set up an account using this code. So my teacher code is 570036. The assignment in there is listed as 7.5A. There are 5 little mini parts to it. I think 2 of them, there's 4 questions each. One has 3 and the other have 2 each or something like that. But remember with Delta Math, if you get them wrong, they make you do extra, right?
Yeah.
So have some scratch paper out. Make sure that you're showing the work on there and working through it slowly so you put the right answer in and don't have to do more problems.